Welcome to clickmyproject.com. We discuss about energy efficient configurations of spatial and frequency resource in MIMO OFDM system. In this paper, we investigated adaptive configurations of spatial and frequency resource to maximize the energy efficiency and reveal the relationship between the EE and the spectral efficiency. In downlink, multiple input, multiple output, orthogonal frequency division, multiple access systems, we formulate the problems as minimizing the total power consumed at the base station under constraint on the ergodic capacity from multiple users, the total number of subcarriers and the number of radio frequency chains. A three-step searching algorithm is devoted to solve these problems. We then analyze the impact of spatial frequency issues overall SE requirement and user fairness on the SEE relationship. Analytical and simulation result shows that increasing the frequency resource more efficiency than increasing spatial resource to improve the SEE relationship as whole. The E increasing with the SE when the frequency resource is not constrained to the maximize the values, otherwise a trade-off between the SE and E exists. The scarification fairness among the user in terms of ergodic capacity can enhance the SEE relationship. In general, the adaptive configuration of spatial and frequency resource output perform the adaptive configuration only spatial or frequency resource. In this flow diagram, we consider for base station data, turbo code and ergodic capacity and three steps algorithm and the energy efficiency. First we discuss about base station. Base station, we allocating the data into several users depending upon the base station. The base station output is given into several data will be split into splitting users into data. The data output is given into the LDPC coder. It is depends upon the turbo codes. Is a linear error correcting code, a method of transmitting a message over a noise transmitting on channel. The noise threshold defines an upper bound for the channel noise. LDPC is also used for 10 GB base Ethernet, which send the data is to 10 gigabytes to wire the pair cables. The ergodic capacity can be total number of subcarriers occupied by multiple users in an integer that is nearest to the sum of the continuous number of subcarriers. We discrete the number of subcarriers for each user. We initially assign user with the integer part of the continuous number of subcarriers. The output is given into three steps algorithm. Three steps algorithm depends upon the ergodic level. The output can be split in the three level format. Finally, we discussing about the energy efficiency. The energy efficiency will be calculated. The energy will be reduced. The equivalent of the systems. First, we selected for main.m and right click to run the file. The process will be running. Please wait. It is represent for the ergodic capacity for 5, 10, 15, 20, 25 in different users. We are allocating for transmission level of each level users. Next we calculating for energy efficient depending upon the secondary users. It is can be represented into 10, 20, 30, 40, 50, 60. It can be represented into several timing allocation. The allocation of the timing level will be calculated. The calculated output will be shown. It is represent for number of RF chain and secondary users. Equivalent of the individual capability levels will be variation according to the input signal level. The output will be shown. The channel estimation level and the signal to noise ratio level depending upon the 5, 10, 15, 20, 25 according to the estimation level of error. The bit rate will be calculated. The calculated output will be shown. Thank you. The secondary user and the energy efficient bits will be calculated into depending according difference level. The calculation output will be shown.